In this video, I will show you how to add 3 vectors by triangle method of vector addition. In the previous video, you have seen how to add 2 vectors. Now I will extend the same thing for 3 vectors. In the previous problem, we had 2 vectors, vector A and vector B. Let us bring one more vector, vector C, which we have to add to these 2 vector. Let me introduce you vector C. This is Mr. Vector C. Now we have to add vector A, B and C. Fortunately, our task is simplified as we already have the sum of vector A and vector B. We just have to add vector C to the resultant of vector A and vector B, and we will have the resultant of vector A plus B plus C. So from the previous problem, I have the resultant of vector A and vector B. Let me call it A plus B. This was the resultant of vector A and vector B. This is our step 1. Now what I have to do, I have to add vector C to this resultant. That will be my step 2 and the final step. Let me copy this resultant of A and B to the step 2. Now I have the resultant of vector A and vector B. I just have to simply add vector C to the result of vector A and B. I copy this vector C and add it to the resultant of vector A and B by triangle method of vector addition, which says to add 2 vectors I have to arrange them head to tail and join the free ends or complete the triangle. I have the resultant, and again I will bring the resultant from nowhere like a magician of vector A plus B and vector C. So here comes the resultant of the 3 vectors. Please welcome Mr. Vector R, the resultant of 3 vectors A plus B plus C. So in this method you have seen how we have added vector A, B and C when we already knew the sum of A and B. But one thing, if we haven't done the previous exercise or you haven't seen the previous video, then this task may seem very difficult and cumbersome. You have to add A and B, find the resultant A and B, and then add C to the resultant, then find the total resultant of the 3 vectors. But by carefully examining this final step, the step 2, you can notice one thing, that you can totally omit the intermediate step. I can simply place vector A, B and C. See carefully, if I place vector A, B and C head to tail and then join tail of first vector to the head of last vector, then I have the total resultant. I do not need this intermediate step. I can totally omit this. If I delete this, then also, although my diagram is not to the mark, let me move C somewhat closer. Now it's right. Now you can see I don't completely need the intermediate step A and B. If I have the vectors A, B, C, I can simply arrange them head to tail and join the free ends. So what is this? The previous method was called as triangle method. Now I have 4 vectors, so I can call it quadrilateral method. Or if I have 4 vectors, then the total will be 5 vectors, 4 plus the 1 resultant vector. So if I have to add more than 2 vectors, 3, 4 or 5, I will arrange them head to tail and I will be left with two free ends, one the tail of first vector, another the head of last vector, in this case vector C, head of vector C, and tail of first vector, vector A. And then how to obtain the resultant? I will simply join the tail of first vector to the head of last vector, and I will call this method, and this method is obviously called as Polygon method of vector addition, or the Polygon law of vector addition, in which you can find resultant of more than two vectors by arranging them head to tail.